This is the project demonstration for the P2P file sharing system. So to start with, we'll show how it runs on the CISC computer systems. So as you can see, it's connected to right now storm.cisc.ufl.edu. So we have first created 5 peers that perform the P2P file sharing. So here, since the terminal does not show the entire output at this moment, we'll show it to you through the log files. So just considering two of the peers, 1002 and 1004. So here, if you check 1002, it did not have the file. So you can see the messages first saying that peer 1002 is connected to the other peers, and then it's unchoked. And then you can see that it downloads the file pieces one by one. And as we go towards the end, you will be able to see that the complete file has been downloaded by peer 1002. Now, you can also notice that it's downloading from the different peers that are available in the system. If we take a look at peer 1004's log, for example, you can see that first it makes a connection to peer 1002, then it receives an interested messages, and then it receives have messages from 1002. Now, it also does random unchoking of the neighbor, that is peer 1002. And finally, the all file pieces are sent from these different peers to peer 1002, and the log files are generated for each of the peers. So as you can see here, we have connected to the CIC systems. So that is Lin 11400, and we have done so for 5 different peers. So another point to note here is that now every peer has the file. So the file we share is called dog.jpg, and you can also see the temporary files in the temp folder that was created during the file sharing. Now, since the file sharing was taking very long and it was very slow on the CIC systems, we will show you how to execute it on our local systems. So here, this is the pure info config I'm using for the local systems. On the CIC systems, this is the pure info config file that was used. So two peers were given the file, and the remaining were not given the file. And on the local systems, right now will be creating 5 different peers for execution. So as you can see, there is no folder generated for the peers. Now I'm starting the peers, and I've started 5 peers, and you can see that the file sharing is happening between the peers. And at this moment, only peer one has the file, so the rest of them will be downloading the files. So you can also see the log files being generated here. So peer one already had the doc.jpg file. So you can see that all the other peers have connected to peer 1001, and it receives the have messages from its peers. It also randomly unchokes certain peers. Now you can see all these peers have downloaded the complete file. So we can also check the logs for them. So for example, if you take a look at peer 2, 1002, you can see that it's downloading each piece one at a time. And once the individual pieces have been downloaded, it should have downloaded the file completely. You can see here peer 1002 has downloaded the complete file. And once a peer has completely downloaded the file, it sends the not interested message to the other peers. So at the beginning, you can see that these peers are also connected to the other peers. So this is a demonstration of how the peer-to-peer file sharing system is running.
Yeah, so I will explain each line of code like quickly. So the bitfield.java file, what it does is like it gets the number of pieces and it distributes the image file into the given required pieces, and that is being used while downloading the pieces by different peers from different one another. Common config class is being used to define common configuration parameters for the networks. This file passes the common.cfg file and like it determines it in each of the variables that can be used in different classes. Constant.java contains different fields which store the information for the header information and the message type, which can be used, which are eventually used in endpoint.java, which is a class that handles all the handshakes and the messages. uh, so this custom formatter message, we used our own util.logger, and to format the logging logs into the given format, we use this custom formatted.java class. So the main code is being run through here. So this is this implementation, it is responsible for receiving handshakes and sending out handshakes. It receives the message, and then it uses the constants variables to determine the message type, and then again sends the information to and fro from the peer. It also prints out the peer information as needed in the terminal, and it simultaneously logs them into the log files for future references. Uh, then coming to the peer.java class. So this is the file that we run the process, implements the server and client side functionality of the server peer. So this class, the server side of the peer, it initializes a socket at the given endpoint, and we have a backlog set for 50. So we can accept at max 50 incoming requests. And this one is the client side of the peer. So this sends the request to the server side, and when it receives the connection, it will start the communication from that peer to the other one. And this is also responsible for reselecting the neighbors, which I will explain in this. So this code handles the top downloaded speed neighbors, and it determines, so in the all the top neighbors which have the highest download speeds are selected as the peer neighbor, and the file download process is continued with them. And other than that, they get choked by the peer and the file transfer stops. The random unchoking is also implemented in this class. So after a random unchoking period, it picks out a random peer id from the given selected peers of the list that are determined in the peer info config. And as explained in the project description, the unchoked neighbor can be same as currently unchoked neighbor, so we have implemented that as well. And peer.process.java is the file responsible that we are using in the terminal to initialize peers from different uh, hosts, or your host names. So when we initialize this variable, it is like a common thing. Like, it will first use common configuration class through initialize common config files. Then it will print out all the common config variables there. Then it will read the peer info config lines to determine the peer information, the host name and all. Then it will set up the peer configuration between each other using the peer class that I just explained with the client and server functionality. After each peer is set up, it schedules a fixed rate, and it at every fixed interval of time, it calculates top download speed neighbors and performs random choking and unchoking of the peers.